So welcome to MECH 3341, Numerical Methods in Statistics. Like I said, I'm Ranga Gopalakrishnan, the instructor, and our teaching assistant is Mr. Al Hassan Hadidi, who is sitting right here. He would come to each lecture so that he would also know what's going on in class, and he would be grading all the assignments. So he and I are doing this together. Okay. We strongly encourage email communication. We are ready to meet with you by appointment. If you want to talk, always feel free to swing by. And if I'm there, I would definitely talk to you. Or if I'm busy, I would just request you to email me and find out the time. But a good strategy is for you to email us asking for a meeting time, and we would gladly be able to find time for you. Okay. So don't feel shy. Especially this course is not like your other courses where there's a lot of heavy theory and then some problem solving. This course is almost entirely problem solving. There is not much heavy theory. We are just going to learn recipes, numerical recipes on the go, and keep doing example after example. So if you're of the type who learns by doing examples, this is for you. Okay, so don't. At the end of the course, I hope we would make you comfortable with numerics and programming. Okay. So in the subject line, please state MECH 3341 so that I would, even if I ignore certain other emails, I would never ignore yours, and I would give you priority. Okay, because because you're important. The textbook is the 7th edition of the book by Chapra and Kenal. The bookstore has it. I also put an Amazon link if you are into purchasing or renting. You can find it there. Before I come to the exams, I just want to go and touch upon the course topics, which I've kind of separated into 6 modules: nonlinear algebraic equations, systems of linear equations, interpolation and regressions, numerical differentiation and integration, solutions to ordinary differential equation, probability and statistics. Now, you have taken calculus classes, you have taken differential equations classes, you have done, by this time you have done thermodynamics, fluid mechanics, maybe even heat transfer. You're probably also in senior design. So you know what equations are. You would have a good idea of situations where you need to solve equations. This course is there to give you recipes, to give you methods that you can use. Not all the time the equations will be straightforward with 0, 1, or pi being the answer. Sometimes it's messy, and I'll try to teach you how to handle messy situations. Okay, in mathematics, not anywhere else. Okay, so these are the course, the section numbers from the textbook that we will cover. What I mean by that is you need to go through these sections and also do problems that are tied to these sections from the end of the chapter. So you'll just have to work through as many examples as you can during the semester. That's the simple one-line strategy. There is not like, should I study this, should I study that? Simple, everything, study everything. Okay. And when I show you a sample homework, you'll understand what I mean by that. So coming back to your scoring and grading, there will be 3 exams, each worth 20%. Each of the exams will cover 2 modules. So module 1 and 2 will be covered in exam 1, 3 and 4 in exam 2, and 5 and 6 in exam 3. And I have planned these exams at these dates. So you can see here, September 21st, October 24th, and December 5th are the 3 days where we plan to hold these 3 exams during the lecture period at this time, okay, in class. It might shift around a little bit. 21st may become 26th, or 24th may become 26th, but it won't shift a lot. Okay, that's what I'm trying to keep up with, so that if I can finish up discussing module 1 and 2 by September 19th, you would have the next exam on the 21st and so on. Any questions so far? Please feel free to stop me and ask. Okay, right. So there will be 3 exams, each worth 20%. and there will be 6 homeworks, one for each module. Each is worth 5%, so that's 90% of your grade right there. 60 and 30. Okay. I have put 5% each for class participation and attendance. Attendance is simple. You show up before I take the call, you're there. If you came in after I took the attendance, on paper, you're not there. Okay, this is just something I do to kind of ensure that people show up on time when they are supposed to. I understand you have other classes, traffic, car troubles, but I strongly encourage you to plan for everything and show up on time. Okay, if it's a genuine emergency, we can work it out. And even though I put it as 5% attendance, if I look at your attendance at the end of the semester and it's been like 1 or 2 sporadic events where you didn't show up, that's definitely something I won't penalize you for. But if it's a pattern, definitely I will tie this 5% to the percentage of the time you actually showed up in class. That makes sense? So I'm not trying to be strict here. I just want to kind of build a habit. Okay. Class participation, 5%. So this first 10 minutes of silence gives me a little bit of nervousness. Want you guys to participate, ask questions, make remarks, kind of talk back to me when we are discussing concepts. I want you to be engaged in the class, and I will try my best to bring that in the lecture. So I sent out emails saying that we would be doing programming, and I asked you to, yes, sir. I sent emails asking you to bring your laptops to each lecture. We would be doing pencil and paper calculations. You would also implement that in Excel. So when I talked about doing a lot of examples, I will first teach you how to implement something in Excel while also doing it on paper, so that when you do a problem, you would have your Excel code or your MATLAB code ready to check your work. So that you don't need me or the TA each time to look over your work. The numbers are there for you to compare. And good engineering judgment is built when you are able to pose a question, solve it, and also validate your solution. If you don't know how to validate your work, you're kind of stuck there because you will constantly be second guessing or wondering if you're right. You should know, not wonder. Okay. Question?
So when you're using Excel, you use other ones like Sheets.
Spreadsheet softwares. Let's put it there. If you want to use Google Sheets or anything else in Linux, that's fine. You had a question?
Yes. Say you came in, or say we had our stuff here in 5 minutes before class started, we went to the bathroom, and we weren't getting, we came in 2 minutes after class started. Would that be?
No. When I call your name, I'll call it twice. If you aren't there, you aren't there. We don't have time to deal with these kind of I was there. All this is not worth our time. We have only 85 minutes to actually learn something. Okay, does that answer your point?
Yeah.
All right. All right. So we talked about 100%. Optionally, that is at the end of your at the end of the semester, if you figure out that you are of the 60%, if you had gotten 60%, good for you. You're doing good. But suppose your performance was not as good as you wanted it to be. I give you an option to take a comprehensive final. Comprehensive means it will cover all the 6 modules, whereas these 3 exams will cover only those 2 modules per exam. So if you take the comprehensive exam, which is worth 60% of the grade, the higher of the 2 scores, that is either the higher score out of this 60% or the higher score of this 60% will be counted for your final grade. So suppose you took your chance and you took the comprehensive final, and as it may happen, you scored less in this than in that, I would forgive you and take the larger score. I am doing this purely so that we give you a second chance to get a better grade. Period. I'm not trying to trick you. Okay? That makes sense? So this is there, the option is there. You can decide pretty much on study day after you see the letter grading scheme that I'll release around that time, and then decide if you want to take it or not. Yeah, we'll talk about it at the end of the semester. It's not something you should worry about right. Okay. And I'm deliberately not holding back about whether the grades will be curved or there will be absolute grading. I'm holding back that information because it usually kind of becomes a preoccupation in students. They think that if it's a curved class, I just need to do better than the average guy. If I were you, I would just focus on getting every point out of this 100%. One thing you can take for sure is if you miss a homework, if you totally miss a homework and get a 0%, you are likely to lose a letter grade or step down by a letter grade. So suppose you are on track to get an A, there is no way you are going to get an A if you miss an entire homework. Okay, so please don't miss any homework. Definitely don't miss any exam, even if you're planning on taking the optional final. Yes, sir.
Sure, on late homework.
I haven't thought of it at this point. In graduate classes, I do it differently than in undergrad classes. Usually whether it's attendance or homework, unless there is a excusable reason. For example, if you or your nearest family members got sick or somebody, it's an emergency situation, I can definitely work with you. But I don't want to give a blanket policy, giving everybody the license to be late and then, all right, I'll just lose 30% here and I'll still be late. I don't want to encourage it. Somebody else had a question? And you will see why you don't need a late homework policy. When I show you the homework, it's actually I keep it simple, okay? I'll tell you how. All right. Important dates, these are just from the university calendar. Yesterday was first day of the semester. Our next break is Monday, which doesn't matter for this class. We'll have fall break, Thanksgiving, and then our last lecture will be December 5th, on which I've scheduled an exam. And then the final will take place in this week at a centrally scheduled time. Okay? You know the drill. Important information. As necessary during the semester, I will make some course corrections if I find something has to be changed. Okay. And part of those changes will also be based on your input. So if you have difficulties, if something isn't working or something is working well, I would really appreciate if you come talk to me, send me an email, write it on a postcard and slip it under my door, whatever works for you. If you don't want to identify yourself, totally respect it, you don't have to. But even if you say something isn't working, I promise you, I assure you that as a teacher, I will take it in the best spirit so that you don't have to feel like saying something will jeopardize your grade or your scores. It won't, I assure you. Okay. So whenever you have feedback, in whatever form, bring them to me. The exams are designed to understand your, for me to understand whether you understood the material. It will not just be plug and chug. It will not be just to solve problems. It will not be like give you an equation, say solve for X, and then ask you to provide X. It won't be that simple. It will be somewhat detailed, and the homeworks are supposed to kind of prep you for that. There will be no other exams than what is described there. So there is three midterms and one optional final, 4 at maximum, 3 for everyone. That's it. There are no more makeup exams. If on study day or even after the final, if your score isn't as good as what you want to be, I will not offer any makeup instruments, be they assignments, projects, or exams, for you to make up a grade. I'm saying this on day one so that nobody comes to me later and makes a request, which I'm declining right now. We are clear? Okay. Students with disabilities, If you have a documented disability, please contact DRS if you already haven't. And whatever accommodation you need, I will try my best to provide it. If not a documented disability, but if you have any kind of request for help you learn better, you are welcome to bring them to me. If I'm able to accommodate it, I will try, but no promises. Okay. Class conduct. So we live in the cell phone era. I understand we all have cell phones, even I have mine on vibrator if my wife calls about a baby or whatever. But please don't use cell phone or don't actively engage in talking, texting, chatting with your neighbor. If you really are not interested in the class, I'm telling you, you could actually just either leave, which I won't take offense. You can get up and leave in the middle of lecture. I really don't mind. But please do not create any kind of conversations. The conversation has to be between me and you, or if we separate ourselves into groups for any kind of like problem solving, it can be a group conversation, but it can't be two people arbitrarily talking to each other and disrupting the class. That's important. Please bring your laptop with Excel and MATLAB. We will be using it on and off. The good news is we will be using it for learning, for trying to understand how the solution process works, but all the exams will be pencil and paper. So you don't have to do your programming in a high pressure ticking clock situation. You just have to do it in class with me, and I'll try to help as much as I can. Okay. Questions so far? Yes.
What is the exam format gonna be like?
Uh,
Paper with laptop and MATLAB or something?
No, just pencil, paper, and a calculator. That's it. 3 or 4 problems in that 80 minutes, and just pencil and paper. You don't have, that's what I'm saying. No programming during the exam. All programming will be done in class when we are learning. Yes.
So how is our homework set up?
I'm going to talk about it. All right. So then here is a declaration that I'm asking you to sign after you have fully understood what the syllabus contains, so that I'm aware that you are aware of it. Okay, later you cannot claim that I wasn't aware. You are, because you signed on. Okay. All right, so this is just an example, okay, to show you what the homework is going to entail. Here is homework 1. It lists the section numbers in the textbook that is covered, that will be covered. It says, for practice, please work out problems at the end of chapter 5, 6, and 8 of chapter and canal. Chapter 8 is sort of like applications. It basically talks about word problems where they give you a situation and you have to distill the equation and then solve those equations using these techniques. Okay. Each homework will contain 1 or at the maximum 2 problems. Okay. But to do this one problem, you will have to work through probably tens, maybe 10, 20, 30, 40, depending on how comfortable you are. You have to practice in order to be able to do. We are having a class that has 36 students. There are 6 homeworks. So you can imagine how much grading there is. So in order to keep it practical, I'm having you solve one detailed problem. So if you go through this problem 8.48 in the textbook, it talks about a certain physical situation like a flow problem. It sets up the equation, it asks you to set up the equation. And then I'm saying, solve that equation using 6 different methods that we will discuss. And in each, you will try to point out how many iterations that were needed and what was the error to which you were able to get the solution. So at the end of the exercise, you will have a good idea of which is the best method in terms of error, in terms of iterations, in terms of ease of use. This course in a broad sense, it's like buying a car. You go to the car dealer, you test drive 3 or 4, and you want to build a database in your head. Oh, if it's a nonlinear equation, I'm better off with secant method and Newton-Raphson because the other 4 are slow to converge or they require initial guesses, whereas these work like this. So you are going to build this experience through these exercises. Okay. Again, you are solving this with 6 different methods. If you get 6 different answers, probably you're doing something wrong. So all of this is supposed to kind of make you think whether am I doing the right. Okay. Somebody had a question about homework. Yes. Does this answer your question? So at the end of it, we want you to submit written work, written down, pencil and paper, steps, the final answer, put it in a table, put a box around it and everything. To check your work, you are encouraged to use MATLAB or Excel, write your own code, verify your work so that when you turn it in, you know that you are giving the right solution and you are likely to get a good score. So you should try to do the programming to your advantage. Does that make sense? But we don't need to see that solution. That's what I'm trying to say. It's for your own guidance. But you can, of course, bring it to us, show it to me, ask me to look it over informally. That I'm happy to. But we don't want to grade 36 pieces of computer codes, each of which will have different types of mistakes, and that's not going to be a practical. All right, good. So then I put all that on record. That is, the syllabus asks you to sign, make sure that you understood what we are doing here. There is still one more thing that I want to share with you. Which is this is something that I'm doing on my own. The university doesn't require me to do this. So you see that we have lectures on these days at this time in this place, which you're all expected to attend. On some days, I'm planning to hold a recitation session, like a problem solving session, 1 to 2 p.m. in this room. Informally, there is no pressure for you to attend or not attend. That session will also be recorded and shared with the entire class. So if you can't make it, you can still watch the recording, where you see that I'm trying to plan 2 sessions before each of the exams. It's kind of trying to give you practice in problem solving so that you'll pick examples from the book and just work it out. No teaching. I won't teach any new concepts. It's just for me to spend 1 hour doing some problems with whoever shows. No pressure. Okay. Again, I may change my mind because on that day something else came up and we push it to another day, but it is my intention to do it so that it will be helpful. So with that, I think I've covered all the things I wanted to say. Any questions? Yes?
Is that schedule on?
No, that is not on Canvas because it's not official. I will make the announcement if it's going to be on the 12th. I will be sure to announce it, say on like a week ahead or something. So if it's on the 12th, I'll announce it on 7th so that people can mark it on their calendars and show up if they want to. One more time, no pressure. If you don't show up, I won't even know. Or if you show up, I won't even remember. Okay? Like, I know I've been a student. Sometimes you snooze with the advisor or the instructor. Trust me, won't work. I could not care less. All right.
Question about the homework.
Yes, sir.
If
need to be turned in on physical paper or turned in digitally on a Dropbox and Canvas?
We are thinking about it, since most of you all write it up in paper and scan it, we might just take a paper submission. The work is not done on the computer mostly, so we might just take papers and return it back to you. All right, good. With that, I think I can actually start the topics. So last thing about these recordings is that in the past, readily available class attendance drops. People decide like, okay, I don't need that 5% attendance and I'll just watch the videos. That is not the intention of this course. It's a lecture-based in-ground class. It's not a remote class. So you are expected to show up, okay? And I'll post these videos with a lag of about a week. You won't get it today, maybe you will get it on Friday or Tuesday. That makes sense? This is not a substitute for coming to class, the recordings. So I have some sheets of the third page printed out, if anybody wants. Let me just. Yeah, I think.
It's like read the emails carefully.
You can give back the science sheet to the TA at the end of the lecture. And just hold on to it until class. Did you want to? Please sign in a pen, please, not pencil. You're all adults or almost adults, and you should know that contracts are signed with pen. Okay? All right, good. All right. So for some minutes until I tell you, feel free to drop your pens and just listen. You don't have to write anything right now. Okay, I'll tell you when to start writing. So if I ask you something like solve for x, Okay, very simple equation, solve for x, saying e power minus x equal to 5. Okay, it's almost beneath you, like you would laugh at me and go, oh, x should be equal to the natural log of, or I'll take the natural log on both sides, it should be the negative natural log of 5. Right? Because this problem has a straightforward numerical solution. It's like almost saying, here is x. Oh, yeah. And I have 0, e power 0 is 1, and that on the positive side it goes to 0. On the negative side, what happens on the negative side? What happens to this function when x is negative? It keeps increasing limitlessly until infinity. E power minus x, if x goes to minus infinity, this is infinity. Right? It just limitlessly increases. So if I say e power minus x is 5, you need to find the value of x. So this is 1. You can draw 2, 3, 4. My drawing skills aren't my strong suit. Okay, I need to find where is 5, and I need to find where it intersects the function, and then I have to read out what this value is, which happens to be negative log of 5. If I say e power minus x equals half, that's the simpler example. You know for a fact that exponential functions always decay, especially if they have a negative sign. So you have exponent of minus x equal to half. You know that e power 0 is 1. That point is here. Everybody with me? Nobody is lost. And you know that e power minus infinity is 0. That is, if you go to infinity, the function decays to 0. You know this. So between 0 and 1 lies half. So you would know that somewhere in between lies my answer. Right? And to do that, you would write minus x equals logarithm of half, or x equals natural log of 2. Looks simple enough, right? I'm going to do this a lot during the semester. I'll ask you, are you with me? If you literally are not with me, you have to speak up. Okay, you have to tell me, and so that we can try a different way of explaining. So now, if I ask you the question, solve for x, e power minus x equals 1 minus x. Don't try to solve it. Tell me something about what x can and cannot be. Don't try to solve it. I'm not asking you for an answer. Let's draw a graph. Okay, that's our best friend here. Can you graph e power minus x for me? If I call this function, say f1 of x, how does e power minus x look like? It starts at, let's say we start at 0, it starts at 1, and then it decays. Okay, what is solving for x? What do you mean by solving? It's like asking for, I'm literally spelling it out. All the things that you have learned from high school algebra to now is literally like saying, for what value of x does the right hand side equal the left hand side? That's literally what we mean by solving for x. So e power minus x is graphed as such. Okay, you can write, say this is 1, this is e power minus 1, this is 2, e power minus 2, and so on. Can you graph 1 minus x for me? How does 1 minus x look like? It's a straight line. Remember your y equals mx plus c. It's like writing y equals minus x plus 1. It has a slope of -1 and an intercept of y-intercept of 1. So it has a slope of -1 and it has a y-intercept of 1. So it has to pass through this point. Okay. It has to look like this. It has to intersect this curve at some point. Okay. So the simplest way to solve these type of non-linear equations. When I say non-linear, they can't be classified as quadratic or linear or cubic, and they can't be neatly solved. They don't have any obvious solution. Of course, when you do the graphing, you'll find out that there is a root. X equal to 0 is a solution. That's obvious, right? X equal to 0. But that's not the only solution. In fact, from just by looking at it, you can't even predict how many solutions there are. You know this, x squared plus ax plus b equal to 0. It has two roots. You know that for a fact. Either both are real or both are imaginary. They can be equal or not equal, but there are two roots. For these type of equations, you can never know fully how many roots there are. Only you have to graph them, and you have to have a range of interest. That is, I'm talking about this variable x. Let's accept one thing. We are engineers. We don't solve everything. We don't solve anything unless there is a purpose for it, unless there is some quantity that you are interested. So if you are thinking about x represents something. It could be the length, it could be a velocity, it could be something. So it has some physical limits on it. I don't care x takes a value of -4000 because my x represents the length. Length can't be negative. So I may be interested, for example, only in solutions which are positive. For example, I'm not saying always that's my interest. I'm interested only when x is positive. So I don't care what happens on this side. Not of interest to me. On this side, I've already figured out x equal to 0 is a solution. I need to find out where else does this curve intersect, or where else these two curves intersect each other. Are we all together so far? Good. That's easier said than done. This is a very simple function. Okay. If you take out your calculator, so I'm going to need some help here, but you don't have to start writing. You just need some numbers punched in, and you are going to help me fill out a table. All right, ready? So we have x, we have e power minus x, and we have 1 minus x. At 0, they are both equal. So we will call that a root. Okay, let's pick 1/2. What is e power minus 1/2? Somebody? Or I will say 0.5. Let's start doing decimals. What is e power minus 0.5? Louder, please. 0.61. Okay, and what is say e power minus 1? Negative half. Yeah, negative half. And what is e power minus 1?
0.37.
0.37. Okay, so I want you to just look at these three numbers, or at least these two rows, And tell me, is there a chance that these two curves can intersect each other in this interval or not? Think of it. Here is 0.61. Here is 0.61, okay? When the function e power minus 6 was 0.61, your other curve was half. So I should have drawn this differently. I'll draw it better. So we have 0, 0.5, 1, and we have 1. So when x is 0.5, 1 minus x is here, and if I join these, right? And where is my e power minus x? So I have 0.5. At 0.5, I need 0.61. Okay, 0.61 should be slightly above. And then at 1, it's at 0.37. Okay. Then I'm missing here. Oh, sorry. You know what I'm missing? I had a different example in mind. So I have my e power minus x, and then I have my 1 plus x. Oh. This makes sense. Just going to switch to Excel and do this. Comes out quick. All right. So I have x, I have exponent of minus x, I have 1 minus x and 1 plus x. Okay. So let's start with 0. So this is exponent of minus x, 1 minus x, and then 1 plus x. So we go for 0.5, 1.0. Okay. So then it's not clearer yet. So let's add more points. So like 0.1, 0.1, 0.2, 0.3, 0.4. All right. So if you look at these two tables, e power minus x and 1 minus x, let's not look at the third column. Just look at these two. If you look, you just scan through the table. Okay, just scan through the table. And where do you see the two functions being the most equal to each other? So if I compute the difference, okay, if I compute difference, I'll say this is absolute value of column C minus column D. So if the difference is closest to 0, that means we are closer to a root. Obviously, we have the x equal to 0 solution here. Let's not think about that. But from the others, this is where the difference is closest. At 0.1, you have this to be 0.904 and this to be exactly 0.9. So the difference is only 0.0048. Okay. So it's clear that a root is likely to be found around 0.1. Question for you, is it 0.1? Why not? They seem equal, 0.90 and 0.9.
So that's
Where? No, if you see the differences, this is the least difference other than 0. So my question for you is simple. Can I call 0.1 to be a root or a solution for this equation? Yes or no? Who said no? Can you please justify? Or can you please elaborate why you are saying?
Well, the roots should be. We want to find a point that's a root, the value should be exactly equal. Even if they're a small bit off, it doesn't mean that they're.
Okay, we'll accept that response for a moment and talk about it. Any other response? Yes.
We just had a, so isn't that why they're so close together?
No. You could have roots that are closely spaced to each other. There is no restriction on that. You could have a solution that 0 is a root and 0.1 can also be a root. There is no restriction on that. Yes.
I would say yes, be a root as long as you account for margin of error.
All right. Can you please elaborate?
Put it simply, if you round to the second decimal place, or for, let's say, your, the accuracy of your measuring tools, you round to the second decimal place, both values are going to look identical at that point. And so, given that real life example, if you count for, let's say that's 0.5%.
We can compute that percent. We don't have to speculate on that. So we'll take this difference, okay? We'll take this difference and then we'll divide it by the value of one of the functions, okay? So this is the percentage difference between the two functions. That is, what I'm saying is at 0.1, this function column C differs from this function column D by 0.5%. 0.5%. Okay, let's keep that number 0.5%. Later, as you keep varying x, it becomes 2%, 5%, 10%, 17, 27, 39, 55, 75, 100%. So if you define, first of all, a root is a point at which the difference between the function is the least. By that measure, it does look like a root. Coming to your point, they are not exactly equal. But the reality is they will never be exactly equal. We are doing a scanning method. That is, you are dividing the interval in steps of 0.1. Instead of 0.1, why not do 0.01? Why do we have to do 0.1? So let's repeat the same exercise with 0.01. And except now, you're not going to have 11 entries, you are going to have 101 entries. So here I am dividing everything in steps of 0.01. And if I, oops. Okay, so now if I scan through my table, okay, now if I scan through my table, okay, other than the fact that 0 is a root, don't look at 0, okay, don't look at 0 or don't look exactly at 0. Other than that, which are the values that are closest? What about here? Hold on. What is this? Yeah. So the difference is closest here, and the percentage is 0.5% here. So can we call 0.9 to be a root, or can we call 0.1 to be a root? If you are looking to match your numbers to only one decimal point, it does appear like a root. But if you want more accuracy, more number of decimal points, then you need to go a little bit finer. So if you see here, 0.11, what's the percentage difference? .11 0.12, where does it actually reach a minimum? Right. So that is like you are starting from 0. That is, if you put 0 as the first entry, then 0 becomes the lowest. You are still in the vicinity of 0. Okay. So coming back to your point, if it's already 0, it can't be something that is just next to 0. It has to be something that is distinct from 0. Okay. So let's put this on the graph. Okay. So the graph will tell you where the two curves actually intersect. Okay. So let me move this to a new sheet. This looks very small, so I need to change it. Okay. So what does it look like here? From the graph, are you able to definitively say where a root may or may not lie? Not really. It still seems like this is the only root. Okay. So I'm going to go make a change here and change this function to 1 plus x and give you a different example. Yes. So I say it again. You want to say -1 plus 10x?
Yeah.
We'll try that. All right. Finally. So I just had to change the example to fit my narrative. E power minus x equals -1 plus 5x. Thank you. So this curve here. So this is your e power minus x curve, and this is the curve of -1 plus 5x. It has a negative intercept and a positive slope, so that we get an intersection point. And if you had graph paper with you, or if you had Excel with you, you would definitely say that the root is somewhere between 0.2 and 0.4, probably after 0.3. Okay, you just have to look at the graph and see where the curves intersect, and with the resolution of your graph paper, you record what is the x value. You just learned what is called as the graphical method. It has very few steps. First, plot the left side and right hand side functions. Identify the point or points of intersection. with a finite resolution. Note down the corresponding x-axis values. That is the graphical method. So this is something you might want to write down. We'll try to do a few more examples, trying to reinforce this. And this is covered in section 5.1. So if you had used a graphing paper literally to graph them and then try to record the x value, you would draw a vertical line and read out what this value is. We did this on Excel on a software. So you can go back to this table. This graph is supposed to narrow down or hone in on where the root is likely to fall, that interval. So you don't have to search everywhere. You just have to search between 0.2 and 0.4, or actually speaking 0.3 and 0.4. So you go back to your table. 0.3 is here, 0.4 is here. And if we scan through the values, the percentage difference hits a minimum of 1.65% only at 0.34. So how would you report this answer? How do you report this 0.34? What will you say as a statement when somebody says solve for x where e power minus x equals minus 1 plus 5x? What is the closing statement? X equal to 0.34 to within 1.65% accuracy. This is key. Sometimes the word I use is good enough. You might not say this in life as many times as you mean it. If you're trying to design a cast iron skillet, which is used for, say, cooking or broiling meat, you need to make it thick. You need to make it thick enough, but you don't have to get the thickness exactly like, say, 4 inches plus minus 1/1,000,000th of an inch. You don't need to get that precise. A resolution or an accuracy of 1% is good enough, because the nature of the process that you subject that device or that design is not punishing enough. Suppose you are responsible for designing a Mars rover, you work for a space company or NASA. This approach will soon get you fired. Because you need to know how much precision and accuracy is needed for the application you are dealing with. There is no blanket accuracy or good enough numbers for everything put together. Does that make sense? What is good enough for one application may not be good enough for any other application. So if you are saying x equals 0.34 and x refers to the position of a sensor or a rotor or kind of a transducer, it depends what you're trying to do. If suppose you are designing a robot and the robot's mission or your design goal is for it to walk straight, make a right turn and leave through the door. Now look how wide this door is. This door is 2 feet, right? So if the robot size is like 1/2 foot and it has to get across a 2-foot door, then getting it right to within, say, 1/10th of an inch is good enough. You don't have to kill yourself getting it to 1/1,000,000th of an inch. But if you are trying to do this for a space application or even defense applications, which are sometimes they have very tight margins, you need to figure out how many decimal points do I need my get my answer right? That makes sense? This is not something that I can tell you 2 decimal points is good enough for this course. That means nothing when you try to do this for your real application. Okay? So if I say 2 decimal points, you can get it 0.34. Beyond that, you don't know whether it's 0.344 or 0.347. You are kind of stuck here. So your answer could be 0.34. It could be a little less, or it could be a little more. Usually, the error, the resolution error, the resolution in our case is 0.01 units. We went in steps of 0.01. Okay. The error that you are committing, the maximum possible error you are committing is half the resolution. In our case, this is 0.005. So your answer is good to within 5 thousandths, 0.34 plus minus 5 thousandths. Okay. If you want more precision, what will you do? You want to add one more decimal point, what will you do? You will repeat this in steps of 0.001 or in steps of 0.005. Okay, your resolution need not be 1 or 10, it need not be in multiples of 10, it could be anything. You can do this 0.32, 0.34, 0.36. Most often, the choice of resolution in computing comes from how much memory you have to store numbers and how much computing power you have to crunch numbers. That is in computing. In experimental work, it usually is determined by how fine an accuracy and resolution you need in your sensor, which is often tied to the cost or the budget available for your project. So if you are given a finite sum, this is just some side like a tangent. If you are given a finite sum for a project and you're asked to do a temperature measurement, you need to first sit and think, with what resolution do I need my measurements? Can I get away with a thermistor which costs 30 cents, or a thermocouple which costs $300, or an infrared temperature sensor that might cost $3,000? So that determines where you put your money. So it's not a business decision, it's an engineering decision. All right, so can I assume that if we want to get one more decimal point, you know how to do that? Can you do that? Right here. All right, so make sure you note down these. Okay, and we'll do one more example. So let's try to solve e power minus x equals cos 4x. Now, I don't even know if this has a solution. Usually, once I teach you the method, we'll try to make up examples, or we can pick ones from the book. Okay, so I'm going to name this example 1. So finally, we decided on -1 plus 5x. Okay. I just want to, yeah. I'll keep this so that I can save these files and share it later. All right. So this is also something you should practice. This course is not about doing 100 problems 100 times. It's about figuring out the algorithm, setting it up, and using it to solve 100 problems. So don't write a code each time. Your code should be broad enough to accommodate many instances. All right. So now we are doing e power minus x, and what's the other function? Cosine 4x. cosine 4x. Okay, so I'll put cos. Let me just make sure what Excel does. Cos of pi. What's cos of pi? -1. Okay, so we have to give this in radians, right? So we'll start with 0, and we'll try to map the function for x goes from say 0 to 8 pi. So if you have your laptops with you, I'm going to do this a little slowly. We have 15 minutes. Let's try to build a program and you can use it later. I'll start from scratch. Okay. So step 1, x min. What is the minimum value of x I care about? 0. And then x max 8 times 5. 8 times 5. And how many points, by how many points do I want to divide this into? You are the user, you can pick it. Right? So I have an interval. Do I want to chop it into 100 pieces or 500 pieces or 100, or what resolution shall we pick? You can do it 2 ways. You can either pick the number of points that will make up this interval. That is, maybe you should listen for 5 minutes and then start working. Okay. So here is 0. Let's say here is 8 pi. Mostly people will be like blindly saying, I'll do this in steps of 0.01. You should think, what is the relevance of 0.01 to the interval that you are thinking about? Suppose that interval were not 8 pi, suppose this were 4000, would you still do this in steps of 0.01? What would you do? Anyone? Loud voice.
Oh, tens.
Tens. So you would take the maximum and you would say, I want to step in 10% shifts, jumps, or 1% jumps, or 0.5% jumps, or whatever percent jumps. So if this is 8 pi, an interval of interest or a step of interest would be 8 pi divided by 100. Meaning I want to chop this interval into 100 pieces. So I will go in steps of 100. Okay, or you can do 1000, that's something. I'm just saying something that is tied back to the length of the interval. And if this were not 0, if this were something else, you could generalize this as 8 pi minus 0 divided by 1000, or step length equals x maximum minus x minimum divided by the number of steps desired. Does that make sense? I'm just generalizing this. So next problem will be some other interval. It won't be 8 pi, but our program will still work. And I want to chop this into 100 pieces. So my step length is x max minus x min divided by number of steps. I'm going to share this file, so we are not able to finish this today. Don't worry about it. Okay. With me so far? We are all good? Yes? So then we'll write x and the function of x we want to compute, which is e power minus x, and the other function of x. So I'll call this LHS and I'll call this RHS equals cosine of 4x. So what is the first value? Or actually, one more thing, I'll put the counter or counter. So first value is x minimum. I have to start with the minimum, right? I have to start with a new. So that is my first value. So I'm going to write it x min plus counter minus 1 times step length. Look at this, and until you understand, we are not going to move forward. Do you understand this statement? I'm looking for my eraser. So the first statement is, I have a counter, okay? I have x, I'm writing x equals x minimum plus counter minus 1 times delta x. In the first entry, counter is 1, that's my start of the count. Okay, you can start counting at 1, 1 minus 1, 0. So first entry is automatically x min. Second entry counter being 2, I just have to copy this formula and before I do that, if you have used your Excel before, you want the C2 and C6 to be the same at every cell. You all took computing class, right? You know MS Excel, somewhat familiar. So you want the C2 and C6 to be the same as you drag this formula down. You do that by going to C2, press F4. Put the two dollar signs in front of and after the C, press F4. What happens is when you drag this cell from F2 to F3, the E will automatically get updated, but the C will remain constant. Just an Excel trick, okay? So I do this. What was my step length? That is, I'm starting here. Oops, where is my marker? I'm starting here. I'm starting here, x min, and my first point, this is x1, x2, what should be this length? This should be your step length. And then if you put x3 is nothing but x2 plus step length. So it's like writing x2 is x1 plus step length, x3 is x2 plus step length, and so on. Yes.
Type of on there without having to have like 100 tall, 100 levels of 100 rows tall. Is there another way to do it, or does it just have to be 100 tall?
Excel, I don't know any other way. If I need to figure out, then let me know. I'm serious. I really don't know any other way. So anyway, is it this stepping here from x1 to x2 to x3? You are just adding delta x to each. So you can write 3.5, and I want to do this for 100 steps, right? I want to keep doing this until your n is 100, and then I just drag this all the way. And what is my last entry? 24.88, 25.13274. That's my last entry, okay? And that is my X max. So I stop when I reach 101 numbers. So if you are chopping it into 100 pieces, you will get 101 number. Does that make sense? Half lost, either lost or lost interest. All right. What is exponent of minus x? Exponent of minus x value. And cosine of cosine of 4 times x. So if I drag these down, we'll see when we graph it. But until this point, can you catch up? We have 5 more minutes or 7 more minutes. Can you populate these two tables, these two columns? For those who are trying. See, I'll show you this x can be done in 2 ways. Okay. One is the formula I gave you. This formula. That is what I put in column G. In column F, I'm going to do something even simpler. I'll call this x simpler. What is the first entry? Sorry? Don't say 0, tell me x minimum. Because the next problem might not start at 0. X minimum, okay? And what is the second entry? It should be x minimum plus step length. That's what you mean. So x minimum or the previous entry plus step length, and I have to freeze step length, so I'm going to put the dollar sign. What is the third entry? Just add step length to the previous entry. That's what you mean. So I can say it should be this plus step length, or like he said, I can copy and paste this and keep on going forever. And you will see that there is no difference between the two. So you can either use that formula, which is really the same thing, or you can do it, just add it to the previous entry. Yes?
Just one to the bottom, because I did it that way, and 500 step was
Yes.
24.88.
I'm getting the same. What was your 100 step? Yeah, 24.88. You need to go to 101. 101 will be your X max. X max is found here. There was another question. Yes. Yep. Yep. Just that. Write it here. I used, say, I use this routine here. X2 is X1 plus delta X. X3 is X2 plus delta X. Just add to the previous one. All right. So now let's graph this. Okay. We'll graph it. Okay. So I'm going to take these three, put them on a graph. Ooh, that looks interesting. All right, we have 4 minutes. Let me do things a little quickly. And before. How about that for an exam problem? Solve for x, for all the roots of x. So if you just look at the interval 0 to 5, this is where the function e power minus x is still nominally non-zero. By e power minus 5 or by x equals 5, this is practically 0. So it's just like a flat line here. So if you're doing some physics or modeling something, that's probably not the interesting range you are looking for. If you look at 0 to 5, right here at 0 there is a root, and around here there is a root, here there is a root, here there is a root. Can you please discuss it? We have 1, 2, 3, 4, 5. At least 5 roots that you can look at just by taking a look at the graph. And if you made this with more resolution, that is, if you you don't need to plot all the way to 25. Let's just say we make the maximum to be 5. That gives you a better view. The first root is at 0. The second root is between 1 and 1.5. The third root is between 1.5 and 2, almost close to 2. The fourth root is between 2.5 and 3, right around 2.75, the midpoint. The fifth root is around 3.5. Sixth root is maybe like 4 and 1/3 or something. Do you see that? So graphical method is not going to be giving you the final answer, but it will quickly tell you where your roots are. And then you can apply the other 5 methods we will learn to get a very precise answer to 5 or 6 decimal points. It's easily possible. So from here, what I would suggest is you can try graphing. You don't have to get the exact answer, but for several such problems, list out the ranges of the roots. And you will never use graphical method as a standalone method. It will be the first step of the next few methods we are going to learn, especially bisection method, secant method, and Newton-Raphson method. They need a guess of the range where the root may lie, and for that purpose, we will use graphical method. Make sense? All right, good. So again, I only give you one homework problem, but that doesn't mean that's the only thing you need to do. You have to practice a lot. Okay. Please go through problems in the book. I'll try to bring more examples in the next day. Thank you.
Will you upload this file on the campus to review it?
Yes, I'll upload it later today.